Hello everyone, my name is Yogesh Punia, and today in this episode we shall be talking about the electric charges, what they are, what kind of charges we have got in our life, and how do they behave when they are in the vicinity of other charges, and what are their distinctive properties because of which they are so important in our life. Long time back, around in 600 BC, the Greeks, they were struggling with a very simple phenomena, yet that was strange to them. They observed that when something that is made from amber, or if we take amber, when that was rubbed with some dry material such as some clothes, or when they have got some hair clip that was made from amber, they used it and they said, oh my god, after I rub this with some dry thing, it has got a mysterious power to attract other lightweight objects such as some pieces of paper or some other things that were really relatively smaller. And they said, oh my god, we don't know what's happening with this problem. And then they said, okay, now since it happened with this piece of paper and amber, we will go for other materials. And after then they did some simple experiments which were available to them at that time, and they said, okay, we have got certain materials, if we rub them with some dry objects, they have the mysterious power to attract other things. But there are also certain materials or certain objects which when rubbed with something, they don't produce anything, and they were left with this question, why is this happening? Then one of a very great Greek philosopher, he said, see, since it is happening with amber particularly, and amber means electron, so they said this is happening due to the electron. And then they said it has got the power of electron, or which is said electric charge, that is able to attract other lightweight objects. And then from this we started a journey which is known as the electric charges, their dominance, and their best thing about them is their beauty in our world. Now since the Greeks gave us this thing electron, we said, okay, we have got electron, now we must find something to discover what is there in this electron. And then we did so many experiments, one of which the budding scientists like you and me, we did in our childhood days. We used to take a scale, we simply rub that scale with our dry hair, and then we will turn out some piece of paper, we will simply put paper here, we will rub the scale over your head, and we will say, look, this is the magic, I am attracting the pieces of paper. And people will say, oh my god, you are a magician. Actually you are a physicist, because you knew the property that the glass scale has got to attract the pieces of paper. This is what the Greeks found out later when they did some similar experiments. Actually what was happening at that time was that they came to know that there are certain charges that are produced when two bodies are rubbed to each other. And they said, since I have got a body A like this and I have got a body B, I have rubbed these two bodies with same material or different materials depending upon the availability. When I bring them close, they will either repel each other or they will attract each other. They said that since the two bodies, this A and this B, they are having some charges, and when we are bring them closer, they have got only two ways of dealing with each other. The one is repulsion and the second one is attraction. They said, okay, when the charges are same, they will say, no, we don't agree with you, we will part apart, or we will repel each other. And when the charges are different, or when they have got the same magnitude but the opposite of their charge, they will say, no, we will attract each other. And then we said, okay, the positive charge or a negative charge are there, and the positive charge repel each other, same way for the negative charge, and hence the positive negative charges attract each other. And then we came out with a generalization that like charges repel each other and unlike charges attract each other. Well, this is what we have got, that we have got two types of charges. One is the positive charge, one is the negative charge. They have got certain agreement with each other that, see, I am positive, you are positive, we will repel each other. I am negative, you are negative, we will repel. If I am positive and you are negative, we certainly will attract each other. Well, this is what we came to know about what are the charges that we have in our daily life and how they behave with each other. And if you go to your home and you look out for certain things like silk or other dress material that your mother can certainly provide you with, you will see that when you rub some glass material or some sort of rods with those materials like the silk one or the nylon, all other, you can clearly say out, okay, this induces this sort of charge, that's why it repels. It induces this sort of charge that attract. Well, I am using a word induces. Actually, this is induces means induction. Induction means if I have got certain charge, that charge will make the other body a bit disturbed. Suppose I have got a sphere, or you say some sort of ball, and I have got a glass rod that I have rubbed with my maybe hair or some sort of material that made this glass rod become positively charged. So it has got some positive charges. Now I will make sure that this glass rod doesn't touch this sphere S, and they are relatively really very closer, just like this. For example, this is a cap that I am having, and if this is a glass rod, so it is coming just like this, but I am not touching them, they are really very closer. So what will happen is that now, since we know what we know that the positive charge will certainly go for the negative charges, and the negative charge will certainly repel the negative charge, and the positive will repel the positive likewise. So what will happen to this sphere is that all the negative charges, when they will see, oh my god, we have got our friend, we have got a positive charge, they will simply rush to him to meet him. And so the sphere, since at this time it has got no charge, so we call it neutral. But when this glass rod is made to enter in the neighborhood of the sphere, all the negative charges will say, we have got our buddy, we are going to meet him, and then they will accumulate near the surface of the sphere. So what will happen? Actually, this is a very simple property that we must take into account. There is a body, suppose we have got this body S. Every body is neutral. Neutral means the positive charges and the negative charges are there. Please don't think that if a body is neutral, it don't have any sort of charge. If a body is neutral, that simply means that there are enough positive charges to counterbalance the enough negative charges that are there, or you may say that the number of positive charges is equal to the number of negative charges. So what happened to this sphere when this glass rod was here? When the glass rod came near to him, the negative charges, they left their places and they rushed towards the glass rod, and hence we were left with some positive charges. This is the property of induction. If we have got certain charged material, and when it is brought into the neighborhood or in the vicinity of certain neutral, say some sphere or some cloth or something like that, actually then the distribution of charges is disturbed, and then that neutral body develops some charges. This is known as the property of induction, that is really very important when we study the electric charges. Now we have discussed what is induction, how a body is said to be neutral, what is the property of that body if that body is neutral, and what happens to when a certain positive body is brought into the neighborhood of a neutral body. Now, since all this game is played by the charges, that is, no matter whether they are positive charges or negative charges, so we must know certain basic properties or certain basic beautiful properties, I must say, of these charges. That is, we will take into account certain properties of the charges, that is Q. So Q is charge that I have taken into account. See, this charge may be positive or may be negative. But what I am saying that q is some charge. When I will go into the magnitude of this charge, then I will say it is positive, that is plus q, or it is negative, that is minus q. So the first property that we are going to study of these charges is that these charges are additive in nature. Well, that is really very quite amusing. You must be saying that this sphere has got certain positive charges and certain negative charges. How can I add them? Means, is it possible? Well, that's quite possible, because you must be remembering the real number line, right? Real numbers, they have got certain positive values, certain negative values, and you can add them. So the first thing is that when we take into account the additive property of these charges, you will say that I have got two charges. First one is plus q, the second one say minus 3q. See, the 1 and the 3, they only tell about the magnitude. So there is nothing to worry about. This could be 100, this could be even 2 or 3. But what we are learning is how to add them. So you can simply add, and if I say the total charge, that is q, that would be this q plus this minus 3q, that will be minus 2q. Quite simple. Now this shows that charges can be added. What are the other properties of the charges? The other property that we are going to discuss is a really very special property. That property is that the charges are not continuous. They are in some sort of quantas, or they are in some positive or negative, that is a different thing, multiples of E. Now if you remember what we discussed in the units and measurements, at that time we said there are, when we express some charges, we express them in terms of electrons or E. So what does it actually mean by saying that they can be expressed in some multiples of E? Because if I say that something can be expressed in the multiples of E, that means it has got some points like this, and that is not continuous. And this is really very different from what we encounter in our day-to-day life. For example, if I have got a wire like this, and if some charge is flowing through it, it will go in a continuous way. There is a point here, then there is a point here, then there is a point here, then there is a point here. You will say no, this is wrong, because this is a continuous line. But the basic thing is that it is not a continuous line. If I draw a very peculiar line between 2 points, suppose this is a point and this is also a point. If I draw between these 2 points with this marker, you can see that I can divide this line into certain points, into certain regions, and when I bring those points really very closer to each other, and I go on making them closer and closer or closer, then only they form a line. And this is what happens in terms of the charges. Actually the charge looks to be continuous only because when we take that thing in the microscopic domain, because in the microscopic domain the amount of charge in a Q is around 1.6 into 10 to the power minus 19 coulomb. Well, this is fine, I can see it, but what about this 10 to the power minus 19? It's literally really very small. So if I go for seeing it like this, here is 10 to the power minus 19, and just near to it there is a 10 to the power minus 19. You cannot distinguish into it whether this is closer, whether this is there are two grains, or they are in a line. So this is what happens with us when we go into the microscopic domain and we look into them. Now with this property we have got also a very good property, that is charge is always conserved. You cannot create a charge, you cannot destroy a charge. Only thing you can do is, just like this neutral sphere, you can make the charges to get redistributed in other parts of the charge. But remember, you cannot create them, you cannot destroy them. So what have we learned in this episode? We have learned that there are some charges that accounts for the phenomena, like when I rub the scale with my dry hair, that attract the particles of some paper, of some other things. Then I came to know that there are certain charges, those are known as positive charges and negative charges. The like charges repel each other and the unlike charges they attract each other. And then I came to know the property of induction, why it is necessary, what happens to a neutral sphere or a neutral body when a positive charge is brought into contact with it. And then I learned about the three major properties of charges, that is, they are always additive. You can add the charges just like real numbers. And then the charges are always conserved. You cannot create them, you cannot destroy them. Now, the third and very important property of charges is that we cannot create or destroy a charge. Just like what we have seen in this neutral sphere or neutral material, we can only go and do some redistribution or do some shuffling in the amount of charges or their places, but we cannot destroy them, or we cannot say I have created this charge and I have destroyed this charge. So with this, what have we learned today? We have learned that there were some phenomena that we encountered in our day-to-day life, like rubbing a scale with our dry hair that was attracting the pieces of paper. There were certain other materials that were attracting each other, that were repelling each other, and then we learned the basic reason behind them, the charges. What are the type of charges? There are some positive charges, there are some negative charges. The like charges, they repel each other, unlike charges, they attract each other. Then we came to know the process of induction and what happens when a particular charged body is brought into contact, and then we learned about the properties of charges. Well, hoping to see you soon with some physical phenomena that fascinates you in the world of physics. Thank you.